Good day, my dear students. This is week 3, exercise 2, mathematics. You know my name, Uncle Law. So today we are going to look into what we call measure of dispersion. Measure of dispersion. Remember, in our previous class we have done measure of central tendency. We made mention of the mode, the mean, and the median in that one. This one now is what? The measure of dispersion. In this one we are going to look at what we call the range, the variance, and the standard deviation. So look at this one. This one says measure of dispersion helps to measure the dispersion. Bracket, you have variation, the spread out of values in a given set of values or data. In that case, it shows how squeezed. It's going to show you how squeezed or spread out or scattered the variable is. These methods used in testing this measure of dispersion are the range, the variance, and standard deviation. And remember that we are doing all these things for ungrouped data. We have range, variance, standard deviation for ungrouped data. We also have the one for grouped data. So what is range? This is what we have been hearing from our primary school. Range of a number is defined as the difference between the highest number and the lowest. The difference between the highest and the lowest. By which the difference now means subtraction. Different highest or the largest number and lowest or the smallest number. So look at it. Range of a given of a set of numbers is the difference between the highest, either you call it highest or largest, and the smallest number. Range is equal to largest number minus the smallest number. Whatever you have there is what we call the range. Let's move. Then, second one is the one we call variance. Variance. Then what is the variance? Say the mean. The variance is the mean of the squares of the deviation from the mean is called the variance. Mathematically, it is referred to as what? Variance is equals to summation of d square. Summation in mathematics means addition. D square now divided by what? N. What is d? D is what? Deviation. Deviation from the number. D is equals to x minus mean. X minus mean. Let me just put this in this way. Let me put the one that we understand. This is our mean. This is our mean. X is variables or data given. Then, the next one is standard deviation. Standard deviation. Standard deviation, it is the most commonly used measure of dispersion. It shows the extent of dispersion of a distribution and it derives from the variance. So they are in sequential order. If you determine variance, you can now determine what the standard deviation. Because it is simply standard deviation is equals to square root of what? Variance. So if you fail to determine the variance, you also fail the what? Standard deviation. But if you get the variance, you will also get the what? The standard deviation. Because it is simply square root of the answer you got in your variance. So summation of d square all over what? N. Square root of all of them. Then let us still move ahead. Let us calculate example. This example says, calculate the range, variance, and standard deviation of the set of numbers. Look at the numbers they give to us. 2, 5, 6, 7, 3, 8, 9, 8. Then, remember I told you that range is the highest number minus the smallest number. If you look at this place now, the highest number here is what? 9. The smallest number here is what? 2. So, range equals to highest number minus lowest number. 9 minus 2, which is what? 7. We are determining that one. Then, for us to get our standard deviation, our variance, we must determine the what? The mean of this. Because this deviation now means deviation from the mean. So look at this place. Mean is equal to this, which is what? Summation of x over n. Summation of x over n. What is our x? X are all these numbers. Add all of them. 2 plus 5 plus 6 plus 7 plus 3 plus 8 plus 9 plus 8. Divided by how many are they? 1, 2, 3, 4, 5, 6, 7, 8. This is this. It becomes mean equals to 48 over 8, which is what? 6. Then you create a table. Put all this number 2, which is 2, 4, 5, 6, 7, 3, 8, 9, 9, and 8. Then this one is deviation. What is deviation? Deviation now means this number x minus mean. Let me change this so that it will correspond with this. So, you are going to determine the deviation in each of these. And what is deviation? X minus mean. Our mean is what? 6. So 2 minus 6 is what? Minus 4. 5 minus 6 is what? Minus 1. 6 minus 6 is what? 0. 7 minus 6 is what? 1. 3 minus 6 is what? Minus 3. 8 minus 6 is what? 2. 9 minus 6 is what? 3. 8 minus 6 is what? 2. Then you square them. Remember that whenever something is a minus 4 squared, it's going to be what? A plus. It's going to be plus. Minus 4 times minus 4. Minus we cancel minus to give you what? Plus. And 4 times 4 is what? 16. 1 square is 1. 0 square is 0. 1 square is 1. Minus 3 square is 9. 2 is 4. 3 is 9. 2 is what? 2 is 4. 2 times 2 is what? 4. So sum, you add all these things, it will give you what? 44. Then we now move back to our formula. Our formula which says that variance is equals to summation of d square all over n. What is summation of our d square? We now pick that our last number, which is 44 over what? 8. What we have is 5.5. This becomes our what? Variance. Then the last one is standard deviation, which is equals to square root of summation of d square over what? N. What do we have here? The whole of this is what? 5, which is equals to square root of variance, which is it is what? 5.5. Square root of 5.5 is what? 2.35. This is our what? Standard deviation. So in this subject, in this topic, which is measurement of what? The measure of dispersion, we made mention of what? things: the range, the variance, and the what? Standard deviation. Of which we said that the range now is the difference between the highest and the what? The lowest. The variance is what? The square root of summation of d square all over what? N. Lastly, the standard deviation, which is the what? The square root of the answer you got in when you calculated for what? Variance. So I have already told you that this thing is very, very simple. You have to put in more effort and continuous revision of it. You solve so many examples in your words, your textbooks. The more you solve, the more you know. Thank you. We'll see you in our next class. Thank you.